You will learn about RAG, Retrieval Augmented Generation. RAG is a technique that enhances the capabilities of large language models, LLM, by retrieving relevant information from external data sources before generating a response. This approach helps to address some limitations of LLMs. What are these limitations? They are two. First of all, you have the outdated public knowledge and lack of internal knowledge. LLMs are typically trained on public data up to a certain date. For ChatGPT 4.0, for example, that date was until October 2023. Second limitation is because companies typically have lots and lots of valuable documents and data that is outside of the reach of ChatGPT. So the question is, how can we make LLMs aware of this public and internal data? Or how can we incorporate this domain knowledge? So there are three solutions. First of all is the prompt engineering. With this solution, you need to be very specific. You tell the version and you give it written examples. This only works if the answer is somewhere in its weights. Second solution is the fine-tuning, where here you start with a base model and add at least 200 examples and run the training again. Fine-tuning is very expensive in the training, testing, and also during the use. The third solution that we'll explore in this presentation is the RAG, Retrieval Augmented Generation. This will enable learning new facts temporarily by doing a retrieval and adding or augmenting the question to the LLM with the data. With RAG, the LLM will be able somehow to get the data it needs. The easiest way to explaining is that you are combining your data with prompts. And in this example, a question answering prompt is used with the three distinct pieces. So the prompt starts with framing, providing the generative AI with the context it needs on how to behave. The user provided question is clearly defined, separate from the framing. Note that in the prompt, we are asking LLM to answer based on the provided data or the provided context. Finally, clearly formatted sources are provided at the end of the prompt. The generative AI synthesizes all this information together and produces a correct response. This is just an example. You may want to consider things in your prompt like instructions to reference citations and sources, explicitly stating, I don't know if the information is not there, is not provided, so that the LLM will not invent an answer. Because at the end it can do that, and that's what is known as the hallucination. So this is the basic user experience for the end user. Let's now see how technically this should work. So first of all, you'd have the user using the application in order to ask a question. Then what will happen later is that an orchestrator somewhere will go to query for the relevant content, the database. The answer would be the search results, which are all the data that are relevant for the question, and that is the first part of a RAG, that is the R for retrieval. So we are meaning here that we retrieve from the database the data that is relevant for the user question. After that, the orchestrator will go to provide that retrieved results to the LLM, to the large language model, along with the user question. So we provide the LLM with the user question along with the data that contains the answer to that question. And then we let the LLM do its magic work by analyzing that data, retrieve the answer, and then frame that answer in a text. And those are the steps that are known as augmentation and also generation for the response. So at the end, we feed the large language model, the LLM, with extra data that will help it to answer the user questions. At the end, the user will get the answer without knowing about all of these technical details. Let's then go in more details with this part that will perform the retrieval of the results. We mentioned that is a database. That database could be a structured SQL database that should support a feature called vectorization. Those are available in databases like PostgreSQL, Azure SQL, Cosmos MongoDB. And this data could be also unstructured data that saves documents, whether those are PDFs, docx Word documents, PowerPoint presentations, Markdown, HTML, or images. For these kind of documents, we need an ingestion process for extracting, splitting, vectorizing, and storing those documents as chunks into the database. And again, here we need a database that supports vectorization, like Azure AI Search, so that it can create a vector for each chunk that it saves. The vector will be used in order to retrieve the searched documents. Let's now go in more technical details about RAG with the embeddings. So the process will always start with the user asking a question. Then the orchestrator will try to get the data from the database that is relevant to answer that question. And to do that, we need first to query the embedding model in order to generate a vector for the user question. The vector, which is a mathematical representation of the user query, will be used in order to search from within the database to get all the results or all the data that is relevant for that user question. Note that the data inside the database is already vectorized. So here we use the user query vector to compare with the existing vectors in the database. And with that way, we'll be able to extract the search results from that search database, and then those results will be sent back to the large language model. At the end, the answer will be sent to the user. In this process, we suppose that the data is already vectorized, but how that vectorization will happen? So let's analyze the complete full RAG flow, where on the right, all will start with the user application. So the user will ask a question. A vector will be generated based on that question. For that, we can use tools like Text Embedding 3 Large, which is one of the models provided by Azure OpenAI. The embedded question, which is a vector mathematical representation, will be sent to the database like Azure AI Search, and then Azure AI Search will get as input that vector, and then it will use it in order to search within its data for the vectors that are the nearest to the embedded question. And because each vector have its own chunk or document, then the related documents will be extracted and they will be sent and embedded to the large language model prompt, and that prompt will be sent then to the Azure OpenAI service or to the LLM model. What's about the vectors and the indexed data? So actually, prior to all this process, we should start from our document library and then perform a chunking process. What is a chunking process? So those documents might be books, white papers, patents, product documentation. So they might be talking about multiple topics within the same document, and the document might be too large, like a book, for example. So we want to chunk those documents into smaller documents or sections. A section could be a paragraph or a chapter, for example. It's worthy to note that there is some limitations on the size of those chunks. Then next we'll go to convert these chunks to embeddings, to vectors. So each chunk would have its own embedding, and this information will be saved to your database. And it will be used in order to compare the user question or the user embedded question to the embeddings that are created based on the chunks or on the sections or on the documents that are provided from our document library. And that's what is known as vector search. Follow me in the next video for a demonstration on how Retrieval Augmented Generation RAG works on the real life. In this demonstration, you will learn how to use Retrieval Augmented Generation RAG with Azure resources and Python application. For that, first of all, we need first to create the Azure resources. So we'll go to create an Azure AI service with a hub and an Azure AI search. You can do this through the Azure portal or the CLI or the Infra as code tools like Bicep and Terraform. Here, for simplicity, I'll do it using the Azure portal. So here I'm within my Azure subscription. I don't have any resource group yet. So here I'll start first by creating the first resource. So I look for AI services, and from within this hub, you will find here multiple Azure AI services. And the one I'm interested in is the Azure AI services, where we'll go to create an AI studio. So from here, I go to create a new resource group for these services. Let's say that's RG AI-services. And then for the location, I'll continue with Sweden Central, but you can choose any other region where AI services are supported. And then for the name, I say AI services demo, and then which seems to not be available. So then I'll just add a suffix. make sure it's available, and then we'll choose the pricing tier. For now I have only the standard S0 available for me, and then next I'll go to the configuration for the networking section, where he will accept to expose those services publicly on the internet for the sake of the simplicity of this demonstration, but not also for the production systems. You can restrict access to that resource. So I'll go to review and create. Once validation passes, I'll create the resource. Once the resource is created, I can go to the resource group, and from here I can see that Azure AI service is created. I can click on there. This will take me to the overview, but I can then go to keys and endpoints to get the keys that I can use in order to connect to this resource. And if I go back to the overview page, then here I get a link that can take me to the Azure AI Studio. I click on that link, and here I'll be redirected to the ai.azure.com. And that's the Azure AI Studio, where we can create LLM models and create applications. Note that here this took me directly to the chat window right here, but for now, because I don't have any deployments yet, so I cannot use ChatGPT from here or any other LLM model. So let's create a first LLM model right here. So we can do that from this button, create a new deployment, or I can just go to the deployments section right here and create a new deployment. Choose here based model, and then we'll get a list of LLM models that you can choose from. So those are models from OpenAI, ChatGPT, models from Microsoft Phi, Facebook Llama, from Mistral, and many more. Here I'll choose the one from ChatGPT. I'll choose the model 4.0, click on that, and then click confirm. And here I'll get a window where I can specify some configurations like the deployment name, the model version, the deployment type. I'll keep these by default, and for the tokens per minute for the limitation, here I'll go to specify the maximum number that I can make, which is in my case 450k. Note that this might change in a future release. Then click deploy. After that, from here we get access to the endpoint, where we can see the endpoint that you can use in order to access this LLM model, along with the key that you can use in order to authenticate and authorize to use that model. So from now, I can open this LLM model in the playground by clicking here, or I can go also to the chat window, and from here I'll be able to view the deployment that will appear right here. And now I have access to my ChatGPT hosted within my Azure subscription. So let's make sure it's working. So let's ask it, who are you? And here for the answer, it's telling me an AI language created by OpenAI. Good, so it's working. So we have created the LLM model. Now we need to create the second resource, which is the embedding model that will be used in order to generate vectors for the text. I'll do that the same way as I did when creating the LLM model. So I'll go again to the deployments, and then from here I select deploy a base model. So this will display all the models for me, but here I want just to display the models that can do embedding. And here we can see some of you models that can do that. And here I'll choose the model text embedding 3 large. This will display here some of its properties, like the maximum tokens that this model can accept, and it's 8,191. So pay attention to this limitation. Later in our demonstration, we'll use this because the chunk or the text that will be analyzed by this model should not exceed this number of tokens. And then the second important thing here is the max output dimensions. So the embedding model will take an input text, and then it will generate a vector. A vector is a mathematical representation that contains a collection of numbers between -1 and 1, or a collection of decimals. And that number of decimals, that's what defines the number of dimensions, and that is by default 3072 within this version of the model. I'm okay with this configuration, so I'll confirm. And then next here we can change the deployment name if you want to. You can choose a model version. You can choose the one that would be always up to date. And for the deployment type, we'll choose here only the standard. That's the only option available for us. And then next, we get here a rate limiting by Azure AI services. So make sure that's the maximum. So then when we do the demonstration, we don't hit any limit. And then go to deploy. The model is immediately deployed, and again from here, from the endpoint section, we can view the URL and the key. Great, so for now we have the two models deployed for ChatGPT and the text embedding 3 large. Great. Now we still miss one thing, that is Why here we have this alert right here that is telling us that we should create a hub and a project in order to unlock all the capabilities of Azure AI services. So let's do that. We can do that either from the Create Now button, or we can also go to Overview, and then from here we can see that for now there is no hub available. So we'll go to Create a New Hub. Click that. This will open a new window within the Azure portal, because a hub will be a resource within Azure, not a resource within the AI Studio. So for that here, I need to specify a resource group where that resource will live. And then we choose a region. I'll continue again with the same region that I've started with, which is Sweden Central. And then let's give it a name, hub demo, for example. And then next here, to connect the AI services to this hub, we need to specify which AI service. So for that, from this list, I can see the AI service that I've created earlier. So I select it. And then next, I'll go to the storage. I'll keep this configuration by default, and this will create a storage account that will be used by Azure AI Studio or by the hub in order to store the files and the configuration. It will also create an Azure Key Vault in order to save the secrets and the certificates. Next, within networking, I'll keep this one publicly available, but for production systems, you can restrict access to some specific networks or some specific resources. Next, with encryption, I'll continue with the default configuration. That's going to use Microsoft Managed Key to encrypt the infra behind. And then for the identity, I'll continue with the default configuration, where here it will use the credential-based access. This means we will use the access keys from these resources to access the resources. So it will not use managed identity, which is the recommended one for production applications. But for simplicity, let's continue with this default option. Then we'll go to review and create. Once the resource validation passes, we'll go to create the resource. Once the deployment completed, right here we can view these resources. If I go to the resource group, and here we can see that there is storage account, Key Vault, and Azure AI Hub. Then with the hub, we need to create a project inside of it. So if I click on the hub right here, we can see that here we have settings for projects. For now, we don't have any project. So we'll go to create a new one. And again, that will go to create a project within the AI Studio. So I'll choose a name for that project. Let's say this is Project AI Demo, for example. Create the project. And here now we are within the vision of the project. Note that there are now multiple or additional items that have been added to this list. So that did really unlock it some more features. The project is available also as an Azure resource. So if I go back to the resource group, hit refresh, then I should see this project resource right here. Great, so we are done with the Azure AI services with the two models. Now let's go to create the last resource, that is the Azure AI search, that will be used in order to save the files and also save the embeddings. For that, I go look for AI search, select it, and that will take me again to the Azure AI services, where here we have the AI search. So I don't have any in this subscription. I'll create a new one. Select the resource group, the same one that I've created earlier, and then give this resource a name. Let's say AI search, for example, demo 03 or SWC, and then choose the same Sweden region that I've selected earlier. And then next, for the pricing tier, I'll go to change the default pricing tier, which is standard. We don't need that for this demonstration as it costs a lot. So for me, I'll continue with the basic one. But note also that the free SKU would be enough for this demonstration. Select that, and then next, for the scale, we'll keep the default configuration. We just need one unit of it, one partition. For the networking, it's going to be publicly exposed to the internet, but note that for production systems, you can choose to privately expose it to your private endpoints. Let's continue with public, and let's hit review and create. Once validation passes, we'll go to create the resource. And here we get the resource created. So if I go to the resource group, then we should see the new Azure AI search service that was created successfully. And from this page, we can see its URL. And from the settings, we can view the keys in order to access or regenerate the keys. Now it's time for a demonstration to see how RAG works with documents and with Azure OpenAI. We'll take a document library that's going to be the Azure documentation for OpenAI, and then we'll use Python notebooks in order to create chunks of these documents and then save those documents into Azure AI Search. And for each document, we'll go to generate an embedding using the text embedding 3 large from OpenAI and save that vector also into the Azure AI Search. Then when the user asks about information that might be within those documents, What will happen is a search that operation that will be performed within the Azure AI search in order to get the sections or the chunks that contains the information, and then those chunks will be passed to Azure OpenAI model like the GPT-4. So then the GPT-4 will get the user question and also the relevant documents, and it will use it to generate a response for the user. In the previous video, we have already created the required resources, which are Azure AI Search and Azure AI Services with Hub and Project. We can clearly see those resources within the Azure portal, and within the AI Studio, we should have here two models, the one for GPT-4 and the one for text embedding. So for this demonstration, we'll use the Markdown documents from the Azure documentation. Those are the documents available on the documentation on this link right here, where you will find information about the different models, how it works, its features, some tutorials, and so on. Those files are available within this GitHub repository, where here you can find the documentation written in Markdown. Each Markdown file contains the content, the title, and the content. So you can just download those Markdown files or this repository by doing a clone on the project. But to make it easier for you to proceed with this demonstration, I've created a new GitHub repository where here within the folder number 100, I put here the documentation from the Azure AI docs. So I save it all those markdown for you. So we'll use this folder as input for chunking the files. In addition to that, because here we'll need to do many operations like chunking the files, saving the data into Azure AI Search, creating the indexes, searching within the document library. So for that, we need to write some code. For that, typically when working with AI, the easiest option is to use Python notebooks. So I have here the Python notebook that will go through all of these operations on our demonstration, along with the description for each one of these operations. So it's right here, and we'll use it for today. I've cloned this Git repository into my local machine, and from here, within the folder 100, I can see that Jupyter Notebook. So let's go through the steps detailed right here, where first of all, we need to install the Python packages. So I just need to click this execute cell right here. And by the way, to have a good user experience when working with Python notebooks within VS Code, you can install an extension. That is this one here. So when you go to VS Code extensions, you choose Jupyter Notebook Renders. And then from here, you click install. Coming back to our notebook. So here first step that we need to perform is to install the required Python packages. Here we will be using Python packages in order to connect to Azure OpenAI, to use the identity in order to authenticate. We'll connect also to Azure AI Search, and then we'll count the number of tokens. For that, we use this tick token library, and we'll load some environment variables. For that, we need the python.env. Once of these requirements are satisfied and are installed, now we can move to the next part, where here we go to connect to the Azure AI Search and OpenAI. For that, here we'll go to use the environment variables. So here I've defined a file called .env that contains all the required endpoints and access keys in order to access our resources. And that file is this one here, .env. So first of all, here we save the endpoint for OpenAI, and for me, it is this endpoint. So how you can and where you can find it. So when you go to your Azure AI resources or services right here, you should see within the overview section an endpoint section, where here you can see the language API endpoint, and also you can view the keys. So I use here one of these two keys. The key is for the environment variable called Azure OpenAI API key. And then next we need the name of the model that we have deployed within Azure AI services. And in my case, it's GPT-4o. So you can find that within the deployment section within AI services. We need also to get the name of the embedding model, which is in my case, this name here, because we need it in the next environment variable for the OpenAI embedding model. And then here we define the dimensions of the vector that we'll be using. So for our case here, we'll use 3072. That's the maximum, but you can specify a lower one if you want to. And then next, we need to specify the endpoint and the admin key for the Azure AI Search. Typically, the endpoint is the name of your AI search with .search.windows.net, and the admin key, that's what you can find if you go to your AI search and then you navigate to the settings section, then keys, and from here you can view those primary key. Great. Then the last environment variable we'll be using today is the index that will be used within Azure AI search. So for my case, I'll use index-doc. Once all of these variables have been set, now we can go back to the notebook, and from here I'll run this code that will go to import those environment variables, and then it will extract values or variables that will take the value of these environment variables. And then next I'll go to create an object of type Azure OpenAI, and then I'll run a test connection to make sure that these credentials works well and I can connect to my Azure OpenAI model. For that, I'll ask my model, who are you? And I'll provide a system prompt saying you are a helpful assistant. Then I should get a response if everything works well. So let's try to run this Python code. Click run from here. This will take a second, and then we should get a response, and this tick right here tells me that the request was done successfully and it took 1.9 seconds. And here following we get the JSON response from the OpenAI ChatGPT model. So here the message that I've specified, here we find its response. So it's telling me I am an assistant created to help answer questions and provide information. Great. So I can connect to my model. That's very good. Next, we'll move to some utility functions like the one here that uses tick token in order to count the number of tokens within a text. And we'll see why this is important in a few seconds. So I'll run this code with a sample. So this will take, for example, tick token is great, this sentence, and it will count the number of tokens. So the number of token is not just number of words or number of characters. It has a specific formula to calculate that. So we need this function in order to calculate the number of tokens. Because in OpenAI, there are limitations, always limitations for the number of tokens that the OpenAI ChatGPT model can accept in input, and also there are limitations for the number of tokens that Azure AI Search can accept to create the embedding. So next here, we'll move to this next part where we'll go to take the input directory, which is data/Azure AI Docs, which is the folder that contains the Azure documentation. Those are the markdown files that I've copied from the Azure GitHub repository. And then we'll go to loop for these files one by one. And for each file, we'll go to count the number of tokens in those files. If the number of tokens is more than 8,191, then we'll show the name of this file. That's because, as per today, 8,191 is the maximum number of tokens that the embedding model can accept. So we'll view those files and we should exclude them from the project. Or better than that, we'll go later to create chunks for these files. So let's run this code. So here it's showing me the name of these files. It's saying this file, for example, is 8,800. So that exceeds the maximum number. And here we have 6 files that exceed. So as we said, for these files, or for all of the files available here, we'll go to chunk them or to divide them within smaller sections. That's what we'll do later. But before that, those are markdown files, MD files, and markdown files might contain some specific characters. If I take a look at this file, for example, so you see here those characters related when you want to include an image or include a link, and those for making the text in italic or in bold. So we want to remove those special characters. We can use some advanced libraries, that way we will make this very easy for us. But here, just for simplicity, I'll just go to remove some specific characters like the links, the images, and the occurrences of the double asterisks. For that, I've created this method called clean markdown content, or I should say function in Python, that will go to perform that operation. Let's run that one. So this is just to compile that. And then next, we'll go to get the vector embedding for an input text. So we have created another function that will take as input a text, and this one will go to create an embedding. The embedding is the vector that represents the text. That's the mathematical representation of the text. So let's run that method, and here we'll run a sample for that method. And we pass here sample text, and we try to make sample text a vector. So the vector is generated right here. So it's multi-dimensions vector that contains decimals from -1 to 1. So we find here all of these values. Those are actually more than 3,000 values, because we have specified 3,000 to be the dimensions of these vectors. So this is a utility method that we'll be using later. Let's now move to the important section here, where we go to create the file chunks. So as we said, those are markdown files that their size exceeds the number of tokens that could be accepted by the embedding model. For that, we'll go to chunk them. And the reason for chunking these files is not just because of the limitations of the embedding model, but it's also because these files might contain lots of topics, lots of paragraphs that each one is talking about a different section or a different topic. So we'll divide each one of these markdowns into multiple sections, or call it chunks. So what we'll do is that we'll take this markdown and then we'll go to split it based on the delimiters that will be the double. This time that means that here we are talking about another section. So here we would have a section talking about GPT-4o and GPT-4 Turbo, for example, and then in the next section is talking about GPT-4 base models, and so on. So we'll be based on that criteria in order to chunk our documents. And this Python code will do exactly that. So it will take that input directory where it will go to create the chunks, and then it will save them into the output directory. That's the data/chunks. It will make sure that file exists. If it doesn't exist, we'll create it, and then it will go to loop for each one of the files within the input directory right here, and it will go to make sure it's a markdown file, because within the documentation we can find some JSON file. We'll go to exclude those files. We'll take only the markdown files, and then for each file it will go to read its content as text, and then it will extract some information like the title, the description, and the date. Note that for each markdown file within the Azure documentation, you have the first section here that contains those information: the title, the description, the date, and many more. We'll use the title and the description in Azure AI Search in order to help to index the documents. For that, we extract those data, and then we proceed to chunking the content file by using those special characters. And then for each chunk of these chunks of the files, we'll go to clean its markdown content. We'll go to remove those links and those special characters, and then we'll make sure that each chunk doesn't exceed the maximum number of tokens accepted by the embedding model. If it does, then we'll go to break and we won't save that file. This is for simplicity, but however, in this case, you can go just to rechunk that chunked document in multiple parts, for example. Or you can go to summarize it and ask OpenAI to create a summary for that, and don't exceed the 8,000 tokens. Then once the chunk is ready, we'll go to create an embedding for that chunk. So we'll call the function getEmbeddingVector. We get the vector, and then we go to create a chunk object that will contain the ID. Here is the generated UID. It contains the page title, description, date, chunk title, the chunk content, and the vector. This is a JSON object that will be saved as a file within the output directory. That's what we do next here. So we create a file name that will be called chunk, the index of the chunk, the page title.json, and then we make sure that the title doesn't contain some special characters by replacing them with empty character. After that, we'll go to write that chunk into a JSON file within the output directory. So we dump it as a JSON file. Let's go run this function. That will take a few seconds. And here it started analyzing the markdown files, and it did also create the chunks. So you see here the number of the chunks. We are getting more chunks created. So for each markdown file, it will create one or multiple chunks. Great. Now once that's finished, we can see that it takes here 2 minutes 35. It depends on the performance of your machine. But here we can see now all of these chunks are created. Those are the JSON files that were generated. And overall, we should have here about 731 files that were created. Let's take a look at these JSON files. Let's take this one, for example. Let's format it by Control or by Shift Alt F. And from here, we can see that each file would have an ID as we have specified within the Python code, and it would have a title, a page description, the page date, a chunk title, and the content. And then next we find the vector that will be generated for that file. Great. So within our RAG flow, we have generated the chunks, those sections, and now we'll go to save those chunks within Azure AI search. We have also used the text embedding 3 large model in order to generate the vectors. So now we'll go to save the embedding and the vector into Azure AI search. Let's do that. So let's continue our Python notebook file. And then here we come to the section where we'll go to work with Azure AI search. So like any database, we should first create the structure of that database. And in Azure AI search, we should create the index for that database. For that, I'll proceed first by importing some libraries that we'll be using, like the credentials, the Azure AI search index client, and the AI search document library. Then next, what I'll do is that I'll get the credentials to connect to the Azure AI search using the environment variables that we have specified within the env file. And then I'll create the AI search index client using the credentials. And then next, I'll go to create a field or the index within Azure AI search. So I'll create an index. I'll go to specify the following fields: a name, a page title, page description, page date, chunk title, chunk content, and vector. And those are the content that we have seen into the chunk or the JSON file, so that when we save those chunks into Azure AI, they will fit the index that we have defined into the Azure AI search. Note that here we specify that this should be searchable for the field vector, because later we'll use the vector field in order to search inside that vector. And then next, we specify the profile, the algorithm, and next we say here we want to use semantic searching. So we'll use the vector search and the semantic search based on the page title. And then next, we create our search index that will have the name that we have specified, that is the name that is index dash doc. And then we proceed to the creation using our imported library through the function create or update index. Let's run this function. And now it tells me that the index doc was created. Let's verify that within the Azure portal. So when I go to my instance of Azure AI Search Service, from here, I should go to the search management indexes. And yes, here I see my index, call it index doc. For now, we have 0 documents, but if I click on that index, we should see the structure that we have created within the fields. So you see the fields that we have created with Python notebook. Great. Now let's go to upload the chunks into this index. That's what we'll do next. Note here I've just added this method in case you want to delete that index and recreate it. So to upload the chunks, we'll proceed with this function. So we'll go to import the client that will use the search client, and then we'll go to loop over those JSON files that are specified within the output directory, and for each file with extension JSON, we'll go to open that file, load it, and then we'll go to use the method or the function upload documents and specify the document we want to upload and print a message saying that uploads did happen successfully. Let's run this code. So it will start by uploading the files one by one. As you see here, the result, when we see it's true, it means that the document was uploaded. This will take a few seconds. Great, now the upload happened successfully, as we can see here. So now if I go back to my index within the Azure AI search, hit refresh, I should see that here I have some documents that are uploaded. So if I click on that index, from the search explorer, we can go to search within those documents. So if I write or if I search for RAG, for example, then here we can get the search results. So we get all the chunks that are talking about RAG. And note here we get those files, their ID, their page title, and we get this search score that will give us a score about how relevant this document is about for my search term. And yes, we get all of the documents related that are talking about RAG. Great, now our data is inside the Azure AI search. So we have performed this step right here where we write the embeddings or also the chunks into the Azure AI search into a vector index. Let's move next in our demonstration where we go to perform a vector similarity search. So we'll do that in code with this simple function. So let's say, for example, I'm again looking for that RAG as I did right here, and you should get those same results. So let's do that, run the code, and yes, here we get those results, but we get slightly different result because here we are combining the vector search with AI search, and that's by getting the embedding that is related to our query. So we get the vector related to the query RAG, and then we'll go to use it in order to search within Azure AI Search. We ask it to get the 3 nearest neighbors within the field vector. So here we disable the searching the text and we enable only searching the vectors. And then from the results, we select those attributes in order to get the page title, date, chunk title, and chunk content. For that, that's what you can see here within this output of that query. Note also you get the score for each one of these retrieved documents. Great. Next, we'll go to the last step where we'll go here to get the user question, create an embedding for that question, pass that embedding to Azure AI Search in order to search the documents that are related to that embedding, and then the returned chunks will be passed to the prompt that will be ingested by Azure OpenAI ChatGPT 4o model in order to use that data with the user query in order to generate a response to the user. All of these steps could be done simply using Python code. So we'll use the OpenAI client chat completions. Then we'll create a user query where here we pass the model name, and then in the messages we specify the role system and the role for the user. That's a bit similar to what you specify here as the system message and then the user query. So for the system, we'll say you are a helpful assistant for an AI engineer. And for the content from the user will ask what are the LLM models supported by Azure. And note here what we'll do is that we'll specify an extra body where we'll tell Azure AI Search or Azure AI OpenAI model, the ChatGPT, that it can connect to my Azure Search database that lives within this endpoint that have this index name, and for the connection can use the authentication of type API key. It can use this API key that I've specified within the .env file in order to search inside those documents. So it will do that automatically for me. So let's run this query. And once that finished, we can see here the JSON response coming from the ChatGPT model. So you can see the answer, the content supports a variety of large language models across different categories. It will name a few like ChatGPT 3, 3.5, Codex, embedding models, and so on. And then next in the context, it will put here the files or the chunks that it did retrieve from the Azure AI Search. We can see their content and so on. So this is all the JSON file that is returned by OpenAI. You can also filter on that JSON file if you want just to get the response and format that response. So here is the response from OpenAI. So it states here all the models that it did support. And that was how Retrieval Augmented Generation RAG works with Python. Thank you.